Good afternoon, everybody. This is Nitin Sukija. Thank you all for joining us in our sixth NAIRR Pilot Researcher Showcase, Empowering AI in Research and Innovation. This showcase is organized by NAIRR Pilot User Experience Working Group. I'm Nitin Sukija. I'm a professor and director for Center for Advanced Computing and Cybersecurity at State University in Pennsylvania. I'll be a host for this panel. This panel is organized by, again, as I said, NAIRR Pilot User Experience Group, which highlights the projects which are using near-parallel resources for excelling AI innovation and discovery. Without further ado, I will be introducing our panelists. We have three panelists today. Thank you so much for joining. Dr. Sachin, Kumar, Dr. Yaoyao, and Marianne Leung. We will talk about these panelists. So first panelist is Dr. Sachin Kumar, who will be discussing his project on reasoning and adaptation for trustworthy, scientific, and safety critical AI. Dr. Sachin Kumar, you can share your screen. Dr. Kumar is an assistant professor at Ohio State University. He obtained his PhD from Carnegie Mellon University uh, after that, he was a postdoc scholar at AI2 and University of Washington, Seattle. His research focuses on developing more inclusive, adaptable, and practical NLP technologies. He's particularly interested in multilingual models that equitably support both written and spoken languages, continual adaptation of NLP models to new languages, domains, and capabilities, personalization to diverse user preferences, and evaluating models on real-world use case and expert domains. He's a Google PhD fellowship recipient in 2012 and received Outstanding and Best Paper awards at ACL in 2003 and 2004. Thank you so much, Dr. Kumar, for being a panelist on this seminar series. With that, it's all yours.
Thank you so much for the introduction, and thanks everybody for joining. So I'll talk about my NAIRR project, which is officially titled, which you see here. It's a bit of a mouthful, so I'll elaborate on the title shortly. So we were awarded this funding in October of last year, and we're very grateful to the NAIRR pilot program for providing us, with the compute resources and the API credits that we have been using. So I'll talk about some of the results we have already. All right, so the main goal of this work that we are pursuing in my lab is to develop AI systems for experts, or providing AI assistance to experts, specifically to scientists and clinicians. So I'll first talk about where AI assistance could be useful for such experts, and how do we evaluate if current systems are in fact useful. And the second part of this project relates to safety. The current systems are designed, or current AI systems are designed to be safe for, general purpose use cases in, specialized domains, like a system deployed within a hospital or another institution. The safety guidelines can be different. So I'll briefly talk about how we can make models more resilient to different safety scenarios without having to retrain them every time for a new scenario. Okay, so let's start with the first one, which is on evaluating scientific ideas using AI. So this project is about developing an AI system that can help you come up with better research ideas by giving you feedback on your current ideas. And I'll give you a brief overview of this paper, which was led by two of my PhD students. You're welcome to check out this link here if you want to try out this system on your own research ideas. I'll have the link again in a future slide if you missed this. All right. So, if you do any sort of research, there's usually four broad steps. You familiarize yourself with the literature in an area, try to identify gaps, unsolved problems, and you come up with a research idea or direction you explore, and then you execute the project. So in a typical computer science research topic, you either prove some theoretical results, or you design experiments, write code, do analysis, and so on. And after you have all the results you like, you write a paper, you summarize your findings, and then you submit to a venue, and the whole process continues. So this is a really long pipeline. It can take months to execute, sometimes years to execute. So in the past few months, we have seen, models like ChatGPT, Claude, whatever AI models, they're getting really good at, a lot of these tasks, and people are trying to use them to automate science. So you might have seen some work on AI scientists or co-scientists and so on. So what we're diving deeper into in this line of work is ideation. So after you come up with a research idea, before you execute it, you want to make sure that it actually a legit idea. Is it worth your time? So even if you're extremely experienced in a topic, this can be a hard thing to do sometimes. Most researchers discuss their ideas with colleagues, with collaborators, work out the kinks, before they start actually executing a project. So that's what we are trying to do in this project. We are trying to evaluate if research ideas are good and worth pursuing, and I'll qualify what good means in a little bit. And like I said, this is extremely pressing right now because AI scientists like AI models used as scientists come up with ideas that appear to be novel. So there have been a lot of work showing that your AI models can generate novel research ideas. But when you actually try to execute them, they are not executable or they have flaws in them. So this can be a big problem because if the ideas are wrong or unfounded, you waste a lot of resources and money, or the AI system wastes a lot of resources and money. And in AI research, that could just be a waste of time or compute resources. But in some other areas, it could be a waste of a lot of money, or you end up buying materials or equipment that or for a project or for an idea that is not going to work. So knowing your idea is good is a crucial first step in all of this, in a research cycle, basically. So that's what we try to develop in this project, which we called Scholar Eval. So we first define what it means for an idea to be good. So it's rooted in already existing literature around novelty and soundness of idea. And our evaluation system is designed to make sure that all criticisms are grounded in literature. So if our evaluation says that, okay, this part of the idea is not good, it provides references and citations as to why this is the case. Overall, we evaluated the system in multiple domains, so it can provide good feedback across scientific disciplines. So we evaluated across 4 disciplines: in computer science, neuroscience, biology, and biochemistry and ecology. So this system provides feedback along 2 dimensions. One is soundness, like I said. So it measures if your idea is logically consistent, whether one can judge the empirical validity of each component of the proposed method. And we do that by looking at other papers that have conducted either similar experiments or used similar experimental setups, what their finding was. And the other component is contribution. So it's a general word for novelty that's used in evaluating papers and ideas. Usually every research idea has multiple dimensions along which it could be novel. So it could be introducing a new problem or a new design or a new evaluation or whatever. So this module is aimed at understanding or judging if any of these dimensions or some of their combinations are novel or already have been studied in the prior literature. I'm not going to go into the details of how they work in the interest of time, but like I said, we have an online demo that you're welcome to check out, and or check out the paper to learn about the details. So I'll just show some examples of the kind of outputs these modules provide. This is an example of weaknesses that the soundness module produces. So it contains, some arguments followed by citations. And in most cases, the citations are relevant to the argument. It's not a perfect system, so sometimes it finds some irrelevant citations. So we're not trying to design a metric. We're just trying to provide a system that can give you feedback that you can improve upon. We also design this in a way that it doesn't just find any relevant paper to the method. It tries to find the first seminal paper that introduces the method and creates like a lineage of citations that cite each other, showing that the current methods are still sound to use. So if an experimental protocol was okay to use 10 years ago, but it's not relevant anymore, the soundness review will take that into account. Similarly, it's for strengths, it generates usually good citations, but sometimes it can generate irrelevant citations, which a person can choose to ignore. And this is another example of the contribution review our system generates. So it identifies, strengths and weaknesses of the methodology of the paper, of the idea, providing again citations and reasoning as to why the proposed method has novelty, but also has some, related work that the research plan does not take into account. So again, like I said, it has a lot of good things, but I'm highlighting some examples of sometimes it can generate vague systems, so vague statements. So, if you use um, the system, if you try it out, please be aware of this. And, if you have suggestions or questions, please reach out to us. Okay, so that's the general idea of the system. Like I said, I didn't go into much detail, but if you access the system, it looks something like this. You can, input your research plan in this text box. It will spend a few minutes to find relevant citations and reasons over them, and generates, the soundness review and the contribution review. And this review, of course, can be useful for a human researcher like any of you, if you're interested to try it out, who'd like to evaluate, your own ideas. But it can also be useful for an AI scientist to evaluate if an idea it generated is good, and use that feedback to iteratively refine it, taking, suggestions of the system into account. So what we're working on right now is using the system as an evaluator to improve ideas that a system can generate. So we did a lot of evaluations in the paper, which you're welcome to check out. But I will briefly highlight the user study we did with researchers from various disciplines, and across all these metrics that I'm showing here, found the systems to be significantly better than really strong baselines based on deep research systems that are out there, and at the same time being much cheaper. There's a lot of other analysis that we did in the paper, both qualitative and quantitative, but in the interest of time, I'll stop on this particular project here. And like I said, it's not a perfect system. There's plenty of things we would like to improve in the system, which you're working on right now. So if you would like to learn more, I'm happy to talk to you over email, or answer questions after I finish talking. Okay. So with that, let me move on to the second part, which is on medical reasoning. So this paper is in collaboration with the medical school here at Ohio State, and it's led by one of my students, the one Lee. So the goal of this project is to study how AI models can assist clinicians or medical professionals more generally. So, if you go to the doctor with some ailment, they usually follow a set of guidelines, right, to identify the illness, they treat you, and then they conduct some standard tests that are prescribed by the guidelines. And this process, works for majority of the people. But oftentimes the guidelines are not enough, especially if the doctor encounters, a rare case. So we did a lot of interviews with various medical professionals, and in rare cases, we found that a lot of doctors, consult external sources when encountering a weird case, weird situation. So the goal of this project is, can we help doctors make decisions, or help provide information more easily to help them make decisions. But if you look at medical evaluations of language models, or all these medical benchmarks, they largely focus on memorization of knowledge. So they don't really focus on rare scenarios. And a lot of these evaluations is kind of multi-choice question answering based. So the testing of the model can internalize certain knowledge. But these models will not be used like this in practice, or AI systems who can do these kinds of tasks will not be really useful in practice. So what we're trying to do in this project is evaluate models in more realistic clinical scenarios. So we develop a benchmark to evaluate models in this project for these rare medical use cases, and we use medical case reports. So the question in our if you use published medical case reports, and medical case reports typically capture some rare scenarios and describe some new test or new diagnosis or things like that. So the questions will be some long form case case description describing detailed symptoms and course of actions taken for the care of the patient. And the questions will be based on the significance of the report. So why was this report written is the reason. The question is based on that reason. We take a lot of care in this benchmark to make sure that the cases that we create are clinically relevant and hard, and the doctors will actually need to look up resources to answer these questions. That's why we work with the medical school, making sure that the benchmark is actually clinically valid. Overall, this is a retrieval-focused benchmark. So given a question, the goal for the system is to find a relevant document that might answer the question, and then use that document to answer the question. So it's a two-step process. First, retrieve the documents, and then answer the question. So it's a retrieval-augmented generation setup. So I'm going to skip over this. It just describes the framework of how we created the system. So we start with a case report and then generate questions from them, and then we annotate. These questions are annotated and edited by physicians for clinical validity. So some quick results, since I don't have a lot of time left. So if you directly pose these questions to the models, we tested like a lot of frontier models, a lot of medically specialized models, and the best accuracy we got for was like 56% on this task. So for almost half the use cases, simply just asking the model is not sufficient. And medically specialized models are much worse at this task, which was surprising. If you try to use these questions to find relevant documents, I don't know if you can see the figure, but these four figures are just recall of finding the right document. And even if we retrieve like the top 20 or top 30 documents, oftentimes we find that in 50% of the cases, the right document that we are looking for is not present in a retrieved set of documents. So the current retrieval systems are also designed around common cases. So even medically fine-tuned retrieval systems, we found that were not able to find the right documents. So they will not be very useful for the current AI systems to surface these rare cases and try to solve them. But the third part of this evaluation is that if we do take like the top K documents and use a language model to answer those questions, some frontier models were able to, like GPT 5.2 that we tested last, or Claude, the latest Claude model, all of these models were able to answer the question like 60 to 70% of the times. So there's some improvement over, the baseline, but the dotted lines here represent like if you do provide the Oracle document to the model. So in that case, some frontier models are able to answer the questions up to 80, 85, 86% of the times. So there is still like a gap that even if you provide the right document, the models can't fill. So even if you find the right sources of information, the models are not able to extract the right answer from them. So this benchmark is meant to test models for both, kind of finding the right information and then reasoning over this information to answer the questions correctly. What we found in this for rare cases, most models currently are not capable of assisting doctors. And these are the use cases in which a doctor might actually want to use models instead of, but current models are mostly focused on, remembering or memorizing, common cases for which a medical professional might not find much use for. Okay, so I think I'm already kind of out of time, so I'll not go into the third project, but the third project is mostly focused on making sure that when these systems are evaluated for medical use cases or used in medical or very like sensitive use cases, the safety guidelines are appropriately enforced, because there's a lot of sensitive data you have to deal with. So in this line of work, we are working on developing algorithms and reasoning systems that can properly be applied to these kinds of systems. So I have this paper linked down here that you're welcome to check out if you're interested in that line of work. But I will not go much further into this in the interest of time. Um, thank you. Thank you for listening.
Thank you, Dr. Kumar. If you have any questions, please put in the Q&A, or you can email Dr. Kumar. With that, we have a next speaker, Dr. Leo, who's going to talk about project meta-learning for robust foundation model adaptation. Dr. Leo is an assistant professor in the School of Information Sciences and the Coordinator Science Laboratory at University of Illinois, Urbana-Champaign. He's also affiliated with the Siebel School of Computing and Data Science and the Department of Electrical and Computer Engineering. Previously, he completed his PhD at Max Planck Institute for Informatics and his BS in Tianjin University. His research lies at the intersection of computer vision and machine learning, with a specific focus on building intelligent visual systems that are continual and data efficient. His research interests include continual learning, few-shot learning, semi-supervised learning, generative models, 3D geometry models, and medical imaging. He's a recipient of the ECVA PhD Award, was recognized as the top area chair at NAIRR IPS 2025, and was selected for the AI 26 New Faculty Highlights program. Thank you so much, Dr. Liu, for joining. With that, it's all yours.
Thank you so much. Thank you so much for the invitation, Professor Sukiya. And I'm very happy to have this opportunity to introduce my work here. So the title of my project is Meta-Learning for Robust Foundation Model Adaptation. Actually, we did some research work, tried to adapt the latest recent large pre-trained models, foundation models, to some interesting application scenarios. So like this is a brief overview of my pilot project. So it's about a foundation model adaptation. So we receive some computational resources from NCSA.ai, GPUs, and also OpenAI API. So we can use this money to use OpenAI API to use ChatGPT model, GPT-5, GPT 3.5, some models like this for vision language task. And I will also introduce about all of these details about how we use the GPU resources later in the following slides. So like here's the motivation of why I want to work on foundation model adaptation. So previously I was working on something like continual learning. This is a traditional uh, machine learning task. So we want to learn the AI models from a continual data stream. Or like I also did something on few-shot learning. That means we want to learn the model from like a field label data. So usually we will summarize all of this research topic as data efficient learning. So we do not have a very good data stream. We do not have a very well-established data set, but we still want to learn a powerful AI model from that. So previously, like from the community, we are working on some standard data set. For example, for me, I'm working on computer vision, so I'm using some data set like C4 100 or ImageNet. So if you are also working on vision task, image classification task, you may also use this data set. They are pretty famous and well established. Like they collect many classes, and like for each class, we have so many training samples, and we use this to establish a lot of benchmark protocol a lot of benchmarks for evaluating the continual learning problem, few-shot learning problem, and so on. So, however, but like recently, like we have like another kind of very powerful models. So, like for example, GPT-5. So it works pretty well for the very large data. Or we have segment anything from Meta, so they can do segmentations to try to segment. As the images, like very many novel classes, and like this model achieves very impressive performance. And for uh, and also for like video or image generation, we have a lot of very powerful generational models like diffusion models. For example, the stable diffusion models, it can produce like photorealistic images. And we also see a lot of like video generation models from the community. So, so I'm thinking about like how to do some adaptations. Previously, we working on like learning continue learning for the standard benchmark for image classification, but is that possible to use some kind of continual learning idea to do the continued adaptation of these foundation models so we can make use of these models for our specific task? So maybe this, for example, for this large language models, they may not work well on some specific domain like medical imaging, or if we want to work on 3D data, it's not possible to directly use the image generation model or video generation model for the 3D to directly apply that on 3D data, but we still like want to make use of the powerful resources from the community to improve our specific task. So that's what I want to do. And so in the following, I'm going to introduce some of my work where like this work is we are trying to adapt some video generation models. We want to adapt some video generation models and we want to apply that to our 3D task. And before introducing the method, I think I should explain like why we want to work on 3D things. So previous AI models, they directly learn for example, if we want to learn some image classification model, we have the input image and we want the model directly map the input image to the final prediction. So we want the input, we want to use the images as the inputs and we want to directly get the predictions from these models. However, for humans, usually we will first have like understanding of the 3D structure of the object and then do predictions based on that. So if we can also learn AI models with 3D understanding, it can help us to, for example, to make the model more robust to occlusions, like out of distribution cases. So what I want to do is that we want to establish AI models with 3D understanding. But to do this, we suffer from some data problem. We do not have enough data. And to learn a model with 3D understanding, the most straightforward way is to have a data set, for example, an image data set, but we have all the 3D annotations. We annotate the 3D pose like of the object. Also, we have all the camera parameters, so we can use this data to learn the 3D model in a supervised learning way. So, however, from the community, we do not have such a data set. So the first data set is called Pascal 3D Plus. It is a good data set, but it only has 12 classes. And it only has 12,000 images. So compared to ImageNet, compared to current large-scale data set, it's a pretty small, like actually very, very small. So it's not very easy to convince the reviewers. This is a very good benchmark for that. And if we want to learn some like large scale models with 3D understanding, it's not possible to directly use this data set because it's too small. We also have some data set that optimize 3D from the community. It contains 100 classes, so it has more classes compared to Pascal 3D Plus, but it still is a very small data set and it's a little bit noisy, so we cannot directly use that to train the model. So I think the most straightforward way to solve this problem is to collect the data. So we recruit people to annotate the large scale 2D image data set with 3D annotations, but it's pretty expensive and also it requires a lot of time. Actually, we did some annotation task, but we also want to look at what we have from the community. Actually, from the community, we have many 3D CAD models. Like there is a very famous data set called Observers XL. It contains like more than 10 million 3D CAD models. So you have 3D models for vehicles, for some animals, for different kind of buildings. So we have a pretty large data set for that. And we also have very powerful image generating models. So for these models, we can use like a language prompt to control the image generation, even though we do not have any information about 3D, but these models, they are pretty powerful and they can help us to produce photorealistic images. So we want to ask, like, can we generate data with 3D annotations by using what we have from the community, by combining the 3D CAD models with 3D with the current recent powerful image generative models. And this is our design. So like we will, for example, if we want to generate an image for an airplane, we will first pick a 3D CAD model from the data set. It's pretty easy because it's a pretty large 3D CAD model data set, and we have more than 10 million 3D models from that. And we can pick an airplane, and we can render that, and during the rendering process, actually, we have all the 3D annotations, all the camera parameters. So we can get all the 3D annotations from this process. And after that, we have the rendered image, but we cannot directly use that because it's like pretty simple, and we do not have like a texture, we do not have a background. But we can use some method to transfer that to some visual problem. For example, we can use the H map, we can use the canny H algorithm to transfer the rendered image to some H map. And we can use this as a visual prompt for the control net for the pre-trained different models. And in this way, so if we use this visual prompt as the condition of the different models and we generate the 2D images, for the generated 2D images, actually, it has exactly the same 3D structure as the original rendered image, and that means during the rendering process, we can obtain all the 3D annotations, and we have camera parameters, we have like 3D information for the poses, we have all the things we need. That means for the generated image, actually, we have all the 3D annotations we need, and we can use this pipeline to establish a large-scale data set. And we also have another pipeline to help us to produce diverse prompts. So like we can change the background, change the texture of the generated images. So because we want to make the data set to be diverse. And here are some visualization results. By using our method, we can create 2D images from 3D CAD models, and we can create very diverse 2D images from different camera parameters, from different background. And in this way, we can establish like large scale 2D image data set with detailed 3D annotations. And previously, for the different models, actually, it does not have any like anything about 3D. It's just the 2D generative models, but we can do some adaptation and to make use of that models for data generation task for 3D. And yeah, here more visualization results. And also we run some experiment, try to use the generated image to train the classification data set, and we get pretty good performance. And I also want to talk about some interesting applications for interesting extensions for that work. So because for the 3D CAD models, for some 3D CAD models, we have detailed part annotations. Also, if the 3D CAD model, if they are animals, if they are humans, usually we will have all the part annotations for that 3D model. That means if we use the model to generate 2D images, actually we can map the part annotation to the 2D image. That means for the 2D image, we not only have all the 3D annotations for the object for the 3D pose, but also we have all the part annotations, and we can also use this pipeline to establish a large-scale part data set with detailed part annotations. Also, this is an extension on the human objects and also on animal objects. For the human models and animal models, they have predefined parts for these models. So which part is leg, which part is arm, something like that. And also we can make use of this information. So in the generated image, we have all the part annotations. And I also want to mention like another interesting work we do is like not for 3D but for 4D. For this work, we work on uh, we work on videos. We want to like reconstruct we want to make use of the pre-trained models, and we want to use the pre-trained model to reconstruct the 4D, all the 4D information in the like in the video, so that and we can like generate. So if we can reconstruct all the 4D informations from the video, actually we can generate videos from like a different camera viewpoint. So here I have a video to show that, but maybe it will take too long time to show the video. But I can show you our project page. So and by using our method, oh, so this is the input video, and oh, the network speed here is not very good. So okay, so I think we can see this is the original input video. We make use of the pre-trained models, and we can extract all the 4D information, and after that we can generate the video from like any other viewpoint. And by doing this, we can do some interesting things. This is like the original video is pretty simple, but we can do something like bullet time. We can stop the like taps we can stop the clock for a while and turn the camera for like 360 degrees and to generate a new video, fancy video like this one. And we also have some more applications. Like we also do some adaptation on remote sensing image. Also, we make use of the models for city segmentations. And if you are interested in my work, you can check the website. And that I want to briefly mention, so I use the OpenAI APIs because for our work we use some language prompt, and we use that from like we can use the large language models like OpenAI or Gemini models. So like I make use of the OpenAI credit provided by the NAIRR pilot. Also, a lot of experiments we run these experiments using our NCSA server. So we have two servers, two clusters. One is called Delta AI, another is called Delta. So I applied for computational credit from Pilot to use these clusters in our NCSA National Center for Supercomputing Applications. And I think this resource is available for all the researchers in, all over the United States. So you can also apply for credit to make use of the GPU clusters from NCSA. Yeah, and that's all the things for my talk. Thank you so much.
Thank you so much, Dr. Leo. Thank you. If you have any questions, please put on a Q&A, and then we'll answer as recorded. With that, I'll have a pleasure of inviting our next speaker, Dr. Marian Leung, who's going to talk about sustainable research pathways for NAIRR, SRP NAIRR program. Dr. Marian Leung is a nationally acclaimed leader in the design and implementation of innovative programs aimed at developing the next generation of science, technology, engineering, and mathematics leaders. Dr. Leung has nurtured her passion for connecting students and science by developing and implementing novel and measurably impactful initiatives. In 2014, she created Sustainable Horizon Institute to increase opportunities for all students at professional in STEM. Dr. Leung's recent interests include development of scalable, parallel scientific codes for investigation of quantum mechanical phenomena, as well as science and technology education, talent development, and creating ecosystem for all. A computational chemist by training, Dr. Leung is an experienced author and researcher. Her research is published in several peer-reviewed journals, and she remains in demand as speaker and contributor at national STEM-based initiatives. Dr. Leung holds a PhD and an MS in computational physics chemistry from the University of Washington. She graduated with honors from Mills College, earning a BA in chemistry with math minor. With that, I will press the mic to Dr. Leung, please.
Okay, great. Thank you, Nitin, and hello, everyone. I'm so delighted to have the opportunity to talk about our NAIRR expansion pilot project called Sustainable Research Pathways. So Sustainable Research Pathways is a little bit different from the other talks that you've heard today. This is a comprehensive talent development program designed to increase the NAIRR pilot participation. So this program, what we do is we start by recruiting faculty and faculty student teams and independent students who are not currently engaged in the NAIRR pilot. So people from all across the US, from all different kinds of institutions, and we particularly focus on people who might not otherwise get involved in the NAIRR. So we also recruit NAIRR project PIs and who are interested in working with new people and sharing kind of your projects and everything you've learned about the NAIRR with people who are interested in trying to get involved. So then we facilitate a matching workshop to help identify collaboration partners. So the matching workshop is virtual. It's held over 4 days, a couple hours each day, and we do a lot of variety of activities to give people opportunity to get to know each other and figure out if there's matches potentially between the people who are participating in the workshop. Once there are matches, we facilitate the process for applying for and getting funded to do actual projects over the summer. So we've currently made our selections already, and we have a cohort of people who will be coming into this summer 2026 to work on projects. And then after the summer, we organize virtual community building kind of summer and post-summer activities. And then we will also fund participants to present the research at a conference in 2027 as part of our building engagement program. So there are 3 tracks within SRP. The first one is the mentor track, which again, so the NAIRR pilot project PIs, if you're interested in getting people to come and work with you on your project. We also have a project track for people that work in the DOE labs, as well as through the High Performance Software Foundation. There's this student faculty track. So these are faculty who apply to participate with their students. And then, as I mentioned, there's a track for independent students who are undergraduates or graduate students, as well as community college students who can apply on their own without a faculty member. So SRP actually began over 10 years ago in 2015, and it started at Lawrence Berkeley National Lab as a partnership between Sustainable Horizons Institute, where I work, and Berkeley Lab. And it grew in the very beginnings from about 30 people to over 60. And so we were placing about 60 people out of 100 in the summer and in the total division. So, really supplying a large percentage of the interns working at Berkeley Lab over the summer within the computing sciences division. In 2021, we were lucky to have the opportunity to expand the program through the Department of Energy Exascale Computing Project. And through that, we supported 60 faculty and students at doing research at 10 different Department of Energy national labs. The following year, in 2022, we expanded through what's an organization called the Computational Research Leadership Council to include non-ECPs. And in that year, we placed almost 200 people into 10 different labs of the Department of Energy. And then last year, we were super excited to get a NAIRR pilot project so that we could extend this opportunity to the NAIRR community. So a little bit about the results of our project thus far. It's still underway, but we had 38 NAIRR projects who responded with interest in participating in SRP. And these projects varied from classroom projects to pilot project to resource allocation, and a lot of different institutions, as you can see from the list here. We had 39 new faculty student teams that applied to be included in SRP. And the 39 faculty student teams included 58 students to accompany their faculty, 19 different states, 31 unique institutions, and 7 different department types. We had 142 new independent students apply to participate in SRP. And you can see here, there was a lot of different states and institutions and majors represented, as well as different academic levels from community college, master's, PhD, and undergraduates. So the matching workshop itself, like I say, it took place over 4 days. It's a virtual workshop, so we can support people all across the US. We start out with a nice welcome and networking session on Tuesday. This is the analog. When we first started this program, it was in person, and that was our dinner the night before we started everything. So it's kind of a fun social activity. And then on Wednesday, we have a welcome and overview, and then everyone gives lightning talks. So we break people out into different breakout rooms based on their interests, and everyone gives a lightning talk to each other. So you get a little snapshot of who else is participating in the workshop. And then the following day, we do kind of a networking session where the project leaders host breakout rooms, and then the faculty and students go and visit them. It's kind of like a poster session where you get a chance to speak more informally and for longer periods of time with people. And then on the last day, we have what we call our speed matching meetings. And this is where we give people the opportunity to meet one-on-one and talk about possible collaborations that I might be able to do over the summer. So the results of our matching workshop are shown here. We are funding over 40 people to participate in the NAIRR projects. So 23 independent students and 7 faculty student teams with 12 students. The academic status ranges from undergraduate through master's and PhD. And you can see we have a large number of states across the US represented, including a number of F-score states. We also have a large percentage of first-generation scholars. Here's a list of the institutions represented by the participants. And so you can take a look at the list, and we really have a wide variety of institutions from Research One institutions down to small teaching institutions, public and state universities, a lot of different universities throughout the country. And then here's a list of the funded pilot projects. The slides will be shared so you can look over there in detail. I don't really expect you to go through them all, and I'm not going to read them all right now, but what you can see is a really quite disparate group of projects ranging from kind of core AI, ML research, as well as a lot of very specific application areas that are looking into different projects. And there's even some also some classroom projects. So this is continuation of the list of projects. So SRP has been around for over 10 years. And like I say, we're delighted to have the opportunity to expand this into the NAIRR community. And we've had really outstanding results from our SRP alumni. Some of the SRP faculty have won the Presidential Award for Excellence in Science, Mathematics, and Engineering Mentoring Award. That was a professor from the City College of New York. Our faculty have been awarded NSF Career Grants, Department of Energy Early Career Awards, Reaching New Energy Sciences, Renew and FAIR grants. So they, the whole idea of this is we create these collaborations and then people go on and continue their collaborations through, getting funded grant awards jointly with their mentors at the labs. And of course, a lot of the work has been published in prestigious conferences and journals. The SRP students have done a lot of amazing things. The undergrads, many of the undergraduates have decided to go on to graduate school where they maybe initially didn't plan that, and then have gone on to win prestigious fellowships like the NSF Graduate Research Fellowship, the DOE Computational Science, and the Stockpile Stewardship Fellowships, winning best papers, presenting their research and whatnot. So SRP is poised to significantly increase the widespread access of resources to accelerate U.S. innovation and competitiveness through the NAIRR pilot project. We work to broadly recruit people all across the U.S. from all different types of institutions. We continue our engagement by creating pathways and support scaffolding, and we foster collaborations in a collaborative ecosystems through the summer and beyond by funding summer research. We organize something called Cultivate Conversations, where Cultivate stands for Catalyzing Ubiquitous Learning through Innovative and Engaging Conversations. And then, of course, supporting the professional development of participants by presenting their research at a scientific conference. So in a kind of nutshell, that is our project. We will be having a matching workshop in November of this year. So if you're interested in participating, go ahead and visit our website. When you get on the website, there is a place you can sign up, get notified when the application opens. And if you have a NAIRR project and maybe you're offering training opportunities, we'd love to be able to share that with the SRP faculty and students. So just drop us an email and let us know. Many thanks to the NSF for our NAIRR Pilot Project Expansion Award and award numbers shown there on the screen. So with that, I think I will stop and be happy to take any questions if there are any, if there's time.
Thank you, Marian. Yeah, we have time. We have 8 minutes. Anyone has questions, you can put your questions on the Q&A down the Zoom. I just have one. There's no question, just UCLA. Chris, it's good to see that UCLA was mentioned one of the projects you had. So
oh yeah.
There's a comment and a question.
Yes, we have people from all different institutions all across the U.S. They're super excited about the response that we've received to the SRP, and already people are getting ready to start their projects this summer.
Thank you, Marian. Anybody else have any question? I don't see any question. Oh, I see something. Okay, how hard was it to get accepted to NAIRR? That's the question for you, Marianne.
I'm not quite sure how to answer that question. We put in a proposal and luckily we got funded.
Well, maybe I can answer it. The thing is, its proposal looks into the NAIRR resources and how you can accelerate and help with the NAIRR usage and utilization. That's the core of the pilot. And if your project is actually helping scientists and researchers and community, which can be classroom expansion and research, then yes, you will be funded. Not sure, but still a competitiveness depending upon what kind of resource you're using. But the goal is that you use resources which are being advertised through NAIRR pilot. Okay, that's the only. Anybody else has any questions? If not, then
so can I just say,
yes.
So if you're new to NAIRR, like you're not involved in NAIRR, but you're really interested in getting involved, applying for our program is a great way to get started, because you get matched with someone who's already working on with the NAIRR, and then you get funded to work with them over the summer. And it's a really good way to start developing your own competencies within your yourself and your organization, so that you can apply for a NAIRR project on your own. That's kind of the idea of the whole thing.
Also, there are many workshops, webinars, and I'll say some small regional, symposiums held by the NAIRR User Experience Group, like this one, and there are also office hours through the experience group. You're more than welcome to join them and seek opportunities. We are there to help. Any question you have, you can join in person and work from there. They're asking. So Patricia has a question. Could you share the link to apply?
For our program, we're not right now accepting applications, but we will be accepting probably late summer. So let me drop the link in the chat where let's see. I'm not sure if it's going to let me. Oh, here we go. Let me try this.
I can just drop the link to the website.
Drop the link to the website?
I can drop a link
because I'm having a little trouble figuring out how to answer it.
Yeah, let me, Patricia, I'm typing the answer. I'm dropping a link to the website for SHI, and you should be able to look at the programs and the dates and the due dates as they open up.
Let me go ahead and share my screen again too. This has the link to the SRP. You can get to SRP from the link that Nitin just shared, but otherwise it's shinstitute.org/sustainable-research-pathways. And then on that page, there's a place where you can sign up to get notified when we open the applications. So that, like I say, right at this moment, we're not accepting applications because we've already selected the class for 2026. But in November of this year, we will have another workshop to select the class for 2027. And that's shinstitute.org/sustainable-research-pathways.
Thank you, Marianne. I don't see any other question. With that, I would like to thank the presenters, the panelists, and the audience to join and get your knowledge enhanced. And we will be doing one more webinar soon in the month of May, and you'll have a month of May or June 2nd or 3rd week. You'll have the announcement soon. Thank you so much for joining us. With that, I'll thank panelists again. Thank you.
Bye, everybody.
Bye,
Thank you.
everyone.